Today we're going to start class reviewing some of the basic concepts with Arduino. What I want to start with first is you've got a sheet with a diagram of the Arduino. I want you on that sheet to go ahead and make a note of the difference between the different pin types that are on the Arduino. So to review, up here we've got a few power outputs and the ground that generally are connected to these two columns right here of holes. On this side over here, we've got pins 0 through 13. These are digital inputs and outputs. We can set them to be either one. Don't worry about these up here that aren't directly labeled. And then here we've got some analog inputs. To practice, let's just take a look at some basic controls for LEDs. And these will be the digital outputs. I want you to build this circuit. This is similar, but a little bit different to how we've been doing it before. Remember that the LEDs have a polarity. That means they have a direction that they need to be hooked up in. And I've got 4 LEDs along the bottom here, and they're all hooked up in a row. And what we have all the shorter leads of the LED on the bottom row here of the breadboard. And then we've got a 220 ohm resistor connecting it back to the ground. And then the long leads here are going to each unique rows in our breadboard. So the first one here is hooked up to row 2, then 3, then 4, then 5. I want you to go ahead and make this circuit. Try to use wires that are as short as possible just to keep your circuit a little bit, your board a little neater. And then don't forget, like we had in the last one, we went ahead and wired up our ground and our 5-volt power supply to these two columns. So make sure those are hooked up like this on your breadboard. Okay, go ahead and pause it and build this circuit. Now let's take a refresher about even all the programming about Arduino. So for your Arduino program, every single program is required to have these two functions, these two lines, void setup and void loop. And you remember that void setup runs once at the beginning when the program is loading onto the Arduino or when it's reset. And void loop runs continually as the Arduino has power. So here's a simple program. We do the void setup. This line right here tells us that this is what we want how we want the Arduino to be configured. Then what we're going to do is we're going to turn pin mode, and this means pin 2 is going to be an output. So we want power to be coming out of pin 2. And then we're going to go to a loop, and we'll digital write pin 2 to high. And then go ahead and make sure your Arduino is plugged in. Remember to go to the serial port. On a lot of the computers, a lot of times you have to select a different serial port and make sure that it is the highest number that's possible. And then upload this program and see what happens. Alright, so there we were able to get one LED on. Let's go ahead and get the rest of the LEDs on. So we would need to go ahead and type in the other pins that are hooked up. We have pins 2, 3, 4, and 5 hooked up. So I'll go ahead and just copy this, paste this here, change this to 4, and this to 5, and now we've declared all these pin modes as output. And then let's go ahead and turn them all on. Alright, so I just pasted some lines here to save some time. And then we can turn them all on. So go ahead and download that. Make sure you've got the semicolons in the right places. Now let's remember how to get the LEDs to flash. I'll use the delay command. The delay is in milliseconds. All right, so we can delay 1000, and then of course we have to get all of these bytes that were on. We have to turn them off. And one more thing, we have to make sure we do a delay at the end, and then we can go ahead and upload that program. Make sure digital write 5 low. Make sure everything is clear in your program. Now go ahead and take a minute or two to experiment and add your own flash patterns in. So I just want to do something like low. All right, we'll have the two outer ones on and then the two inner ones off. And then we'll have the two outer ones off and the two inner ones on. So now I've got 3 different phases, and I'll upload this, and you go ahead and experiment with your own. Next, let's refresh our memories on how we use a button to control the lights. So go ahead and add a button here. Be sure to use the same holes for the wires that I've got set up. And notice here that this right now is now a brown, black, orange, which is a 10 kilo ohm resistor, as opposed to this red or orange, orange, brown. I guess it's red, red, brown, which is a 220 ohm resistor. So pause it and wire this up. Here's our basic setup for the button. You'll notice here that we've got the setup and the loop functions that is required in every Arduino program. We've only got them in once. You can't have them in any more than one time. And here I've just started off with 2 pins hooked up. Pin 2, which is our first LED, is an output, and pin 10 is where the button is hooked up. That'll be an input. Then we have a void loop, and we're going to use this if function. So if, and here we're using the digital read command. So this is asking the Arduino to take a look at pin 10 and tell the state of pin 10. So if pin 10 is not pushed, right, if it's low, then we want the LED to be off. If it's anything other than low, and the only other option is high, then we want the LED to be on. So go ahead and download this and test it out. Now, if you'll remember the Spaceship Interface project that we had, this is similar to that. Just to refresh your memory with that, I've declared 3 of our LEDs, right, the ones at pin 2, 3, and 5 as outputs. And the pin with the button, again, is an input, and this is done in the setup. There's only one setup. And then in our one loop, I've got it examining the state of pin 10. And if pin 10 is low, then I want 2, 3, and 5 to be off, wait a little bit, and 5 to go on, and wait a little bit. So what this will do is this will flash 5 off and on, and make sure that 2 and 3 are always off. And then else here, if the pin state is anything other than low, which the only other option is high, then we're going to turn pin 2 on. Right, make sure pin 5 is off, turn pin 2 on, turn pin 3 off, wait a short amount of time, and then alternate. turn pin 2 on and pin 3 off. And then when you do that, you get a quick blinking of those two LEDs when the button is pressed. Now I want you to go ahead and be creative and see if you can do your own interpretation of this and change this program to do something unique, a unique flashing pattern. All right. So far we've been using the digital write command. And the digital write command has two options. It can either be high or low. So basically it's on full power or it's totally off. And the alternative to that is the analog write command. And here I've got a really basic setup that is designed to use that. Go ahead and type this in and test it out. And you'll notice here that I've used pin 3. And the reason I've used pin 3 and not pin 2, which is kind of the first one in a row, is that if you look at your Arduino board, you'll see that pin 3, you'll see that pin 3 has this little squiggly mark that's a tilde. And that means that it is capable of doing analog write. Only the pins with that tilde mark can do the analog write. If it doesn't have the tilde mark, it can only do the digital read and the digital write. All right, so back to our program. The program here has analog write. So what this means is that again, we've set pin 3 as an output, and now we're analog write, and we've set pin 3, and then this is the value. This is kind of the power level that we want this onto. Our options are between 0 and 255. So I've done this a relatively low 10. If you change this to 100 and upload it, you'll notice that the light should be considerably brighter. Once you get above 100, the power levels are harder to distinguish between, because if you go to 255 from 100, you probably won't notice too much difference between the brightness. A little bit, not too much. All right, so that is how we can do different brightnesses. Now my next question is, wouldn't it be cool if we could get the LED to go from being really dim to being bright, and then back down to being dim, right? So we want the LED to keep getting brighter. So what we need to do is we need to change that value in the analog write. So before we set it to 10 and then we tried 100, let's take a look at this program right here. In this program, same thing, we're using pin 3, but this time what we've done is we have just started off with the power at 10, then waited a tenth of a second, brought it up to 30, wait, brought it up to 50. So this time we are dimming it a little, or brightening it each time, and then it'll go back down. You can use copy and paste and change the values inside there to make it go a little faster, but it's still a little tedious to write this program out. Go ahead and upload this program onto your Arduino, and you should see the LED kind of staggering, getting brighter, and you can see each individual change of brightness. If we wanted it to be more smooth, we could add in some lines that say analog write, and we could write it to a value of 20 and write it to then 30, then 40, then 50, and then that would be a little bit smoother of a change, but that's starting to sound pretty labor intensive. The solution to this is going to be a new programming concept, and here we're going to use a different style of writing. All right, here is our new program. And in this program, we are fading in and out. And we've declared a couple variables to help us. And the variables here are just numbers that the computer is going to store and keep in its memory. And here we're having integers, so 0, 1, 2, 3, 4, 5, -1, -2 are integers. So that's the type of variable we have here. Starting with a brightness and setting it equal to 0. and an integer of fade amount is equal to 5. And so again, we do our setup. Pin mode is 3 is output. Then we're going to do our loop. And here we have our analog write to pin 3, but we're writing to this value. So this value starts off at 0, right? So when this first starts, the brightness will be 0, so the LED won't be on. Then it's telling us to take the brightness and then change it to brightness plus the fade amount, which is 5. So your brightness will quickly go from 0 to 5. Then the next thing is it asks you to look at the brightness and see if it's equal to 0, or, that's what these two lines mean, or if the brightness is equal to 255. And since we just made it equal to 5, it's neither one of that, so that's not going to happen. We delay it just a little bit so that it doesn't happen too fast. And then it goes through here again, and our brightness was equal to 5 before. Now the next time around it's going to be equal to 10, and each time it goes through it's going to increase by 5, and pretty soon it'll get to 255. And at that time it's telling fade amount to change to negative fade amount. So when it gets to 255, instead of adding 5, it's going to add a negative 5. So it's going to get dimmer. And each time it's going to go from 255 to 250 to 245 to 240 and go through until it gets to 0. So go ahead and type this in, try it out. These two symbols right here are the bars. They're above the enter key. You have to press shift and then the backslash above the enter key on the keyboard to get those, and you get 2 of those there. All right. Now that you've tried that out, I want one thing, you can play with this, but one thing to be aware of is if you don't hit 255 exactly, if you change your fade amount to 10, then you won't hit 255 exactly. Your program won't work exactly the way you want. It'll probably just go bright, 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 and then go back down to 0, and then go bright, 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 rather than going bright, getting brighter, then getting dimmer, then brighter, brighter, dimmer, dimmer. The thing you can do if you want to do bigger fade amounts, you can change this to 20, but you just have to then go ahead and make sure that this number is some interval of 20, some number that's divisible by 20 that is less than 255. So go to 240. And then you can upload that program, and it should fade faster than before, and it'll still fade and dim. Good job with making it through those. If you have extra time, I encourage you to try your own projects, try your own flash patterns, try your own, use the button to control different things, and experiment with your Arduino board. All right, I will see you next class, and be sure to clean up all your materials and push your chairs in when you're done.